How we doing? Okay, so today we're going to be using Xfoil. We're going to calculate the lift coefficient, the drag coefficient of a cambered airfoil, NACA 4415. And we are also going to determine the maximum aerodynamic performance and its corresponding angle of attack. We're going to be using two different Reynolds numbers, one at 300,000 and a turbulent flow Reynolds of 800,000. Okay, let's get going here. And here we go. Okay, so let's NACA 4415. First, we're going to type in NACA 4415, and this gives us some data on that particular airfoil. We'll smooth out our panels here, and we're going to go PPAR. Okay, there's our airfoil right there. I'm going to move this over here. Okay, first thing we're going to do is we're going to edit this a little bit. We're going to change our number of panel modes from 160 to 250. And we're also going to change our panel density ratio from 0.15 to 1. Okay, and back to Xfoil. Okay, now operation. First, we're going to start in viscid. There's no viscosity at all. And we're going to change our iterations to 100. And enter, and then we will start our sequence. We're going to SEQ. We're going to start at 0 degrees. We're going to go all the way to 20 degrees. These are angles of attack, and with 1 degree increments in the middle. Okay. Now we're going to set up a file name. So let's go to TACC, and we will name this file NAC, A 4415 Inviscid. This is just the file name that we're saving our data to. Okay, polar dump file, we don't need that. Polar accumulation is enabled. So now we will set our sequence up again, starting at 0 degrees, going to 20 degrees, 1 degree increments in between. And here we go. Okay, so now we can see these are our 20 different angles of attack over here. And this is our data. Viscosity 0. Okay. So now we'll get back into Xfoil, and we're going to do another one, same airfoil, NACA 4415. Enter, just like before. Smooth out our panel here. We're going to go PPAR right there. Again, N250 T1. Enter. Okay, and back to Xfoil. This time we're going to have a Reynolds number of 300 or 300,000. I'm sorry. So we type in VISC 300, 1, 2, 3. Now we are viscosity 300,000. I don't know why that says opera IA. And we will have iterations of 100. Return and a SEQ 0, 21. Okay. And now we will go PACC, return, code accumulation disabled. Oh, maybe we'll start over. Okay, let's go out of here. Actually, let's check and make sure we have our, let's see where our files are at here. Okay, so I go back to Xfoil 2 right here. Here we go. NACA 4415 in Vincent. So we have that right there. Let's log out of this one. Let's go back to Xfoil here. And let's start over. Okay. NACA 4415. Enter. Sorry about that. Enter. PPAR. Enter. There's our airfoil. And come down here. Okay, change what? Change our panel nodes to 250 again. Change our panel density ratio to 1. Okay. OPER. Enter. And we're going to go, VISC 300, 1, 2, 3. Enter. Okay, we're in viscous mode now. Iterations will be 100. Enter. And a seek again, starting at 0 degrees, going to 20 degrees with 1 degree increments in between. And there we go. Okay. So now we're going to set up a file again. And we will call it NACA 4415 RE. We'll say 300,000. That's our Reynolds number. Okay, turn, enter polar dump file. We don't have one. Okay, now we will do it all again. 0, 20, 1 degree increment in the middle. That just saves everything right to our. Okay, so let's look at our, this is our new file with a Reynolds number of 300,000 right here. Move this in the middle. Here's all of our data. There's our lift coefficient. There's our moment coefficient. There's our drag coefficient right there. And these are our angles starting at 0, ending at 20. Okay, let's make sure it got into our folder here. And there it is right there. Okay. So now we're going to do one for 800,000. Right here. Okay. Once again, 4415. Okay. We're going to go pane. And then PPAR, return. Once again, there's our airfoil. And now we will have N250, turn, T1, turn. Oops, enter. Okay. Put our operation in. Our viscosity will be 800,000 this time. Our operation V, we got our V right here. That means we're viscous. Iterations will be 100. Enter. And we will start our sequence here. A seek 0, starting at 0 degrees, going to 20, 1 degree increments in the middle. Okay. PACC. Bam. We will call this file name NACA 4415, Reynolds number 8. Okay. So dump file, aseek 0, 20, 1. Bam. This writes it all to this file. Okay. And now, this is our new graph right here. And we can see, once again, these are our lift coefficients here. Right, here's our lift coefficients, moment coefficients, drag coefficients. This is the top of the airfoil. This is the bottom of the airfoil. And this is our angles of attack. Okay. All right, let's make sure this one went through. Yep, so we have these three right here. We have our invested flow, our Reynolds number of 300,000, and our Reynolds number of 800,000. All right, let's go to Excel. Let's open up Excel here. And we're gonna transfer that data into Excel so we can make a graph. All right, let's browse here. Let's see. I gotta figure out where these things are. They're in my desktop. All files right here. Xfoil, here we go. Okay, so let's start with the Inviscid one. We're gonna go fixed with, next, finish. There's our data right there. Okay, so let's start a new sheet. Okay, so now let's go up here to File. Let's bring in the other ones. Open, browse, and we'll bring in the 300. Next, finish. Okay, there's our RE3. Okay, let's go do one more. Open, browse, and here's our Reynolds number of 800,000 right here. Open that up. Next, finish. And there we go. Okay, so what I'm going to do, take the Inviscid one here. We're going to open a new sheet. And then we'll go with Reynolds number of 300,000. I'm just going to copy all this right here. Copy into the clipboard. Is still paste your content within this workbook. Okay. We'll come over here. Paste. Boom. Right there. And then we'll open. Actually, we'll call this one NACA 4415 RE3. Boom. Okay, now we'll make another sheet here. And we're going to get RE8. Let's copy all this. Copy. And let's go back to here. Paste. Oops, paste right there. Okay, and we will name this one NACA 4415 RE8. Okay, here we go. All right, so back to the Inviscid one here. Let's see, let's start a insert graph here. Start there, that's not the one we want. Whoops. Insert, maybe we'll do this one right here. No, that's not what we want either. Tell you what, start here. Insert. There we go. Select data. Add. Series name. This one's going to be RE number equals 3E plus 5. That's 300,000. Okay. And right now we're going to calculate our lift coefficient versus our angle of attack. So first things first, we're going to collect this data right here. Okay. And it looks like it gave us our 20 points in the bottom. All right, there's that. Let's add some more. We'll next add Inviscid flow. Inviscid flow here. And we'll go to our Inviscid worksheet. We'll add all this data right. Well, here, we got to just go to 20 degrees. And okay. Okay, there's our Inviscid flow. And we're going to add one more. and select data. And this one is going to be RE number, number equals 8E plus 5, that's 800,000. And let's go to RE8. Okay, here's our lift coefficient data right there. Add that in. Okay, and there's our graph. We can expand this, get bigger. This is our lift coefficient compared to alpha. Now we can do our, let's start a new graph here. We can do our drag coefficient. So let's go to insert. It's right here. And select data, add. This is going to be RE number 3E plus 5. Okay, here's all our drag data. Looks good. Okay, now we will select more data, add a new one. This one's going to be RE number equals 8E plus 5, 800,000. Let's go to our data for that. Here's our drag data right there. Okay. Okay. Now we're going to add our inviscid. Select data, add inviscid. Boom. Let's go to inviscid right here. And of course, there is no drag when you have inviscid flow. So we will just have a straight line right across the bottom. Right there, you can see the line. Okay, that's our drag coefficients. Right there. Now the last thing we want to do is you want to make a maximum performance, aerodynamic performance graph. And we do that by dividing lift coefficient by drag coefficient. So what we're going to do is we're going to go equals this, and we're going to divide this, the lift coefficients, by our drag coefficients right here. Boom. Enter, and we get a whole set of data points. And we're also going to do this for our Reynolds number of 800,000. So equal our lift coefficient divided by our drag coefficient right here equals. Okay, let's go ahead and make this graph here. And right, you want to select data. You don't want that one. No. For some reason. Insert. Oh, I don't know why it just keeps adding it to it. Anyway, select data. We will add Jimmy's name, 800. We'll go RE number equals 8E plus 5. And we're going to take these numbers right here. Bam, just like that. Okay. And now we will add another one. This is RE number equals 3 plus 5. And we'll go back to our Reynolds number of 300,000. We will get this data right here. That in. Okay. Okay. And there you can see our maximum aerodynamic performance with the two different Reynolds numbers. So you can put in our legend right here. So we have, this is our Reynolds number of 800,000. This is our Reynolds number of 300,000 right there. So, and that's about it. You can see our our optimal angle of attack for, looks like it's about 9 degrees, maybe 8 degrees, where the aerodynamic performance is optimal. Okay, well, thank you very much. Have a great day.